Okay, so we're starting off this unit. This is a quick unit. We're going to go over weathering and erosion on how we see the Earth's crust on what our visual of the Earth's crust is. So, weathering and erosion. Weathering and erosion are how we have the Earth's surface and how they cause different rocks and minerals to break down. So, weathering is the process of near the Earth's surface. Erosion is the process of moving the materials from the original sites through weathering or transport. So weathering is the breaking down, erosion is the transport, basically. Two types of weathering are mechanical and chemical. Chemical is the chemical change of rocks and minerals, and mechanical weathering is the process in which rocks are broken down into smaller pieces. So we talk about this in chemistry. So this is your introduction to chemistry. So the chemical process is the changing of the chemical composition. A weathering, mechanical weathering is just a physical change. Um, mechanical weathering happens in several different ways. So plant growth or wind, water, gravity. So if you see a rock on the side of a hill, gravity could eventually affect it to fall down. That's why we see different, where you're driving down the highway, you see a sign that says falling rock. It's due to gravity or some sort of erosion. Frost wedging, so as water seeps into cracks, if it freezes, it expands. So water expands when it freezes, so that could cause some sort of frost wedging. Thermal expansion or contraction is when you have either too much heat or too much cooling that is going to cause expansion or contraction depending on what is going on with that particular surface. And plant growth is just like frost wedging, except it is biological. So like we could call plant growth biological weathering. Frost wedging, you take a crack, like I said, you're expanding, you put water in it, and as it expands, it starts to push this out. So frost wedging would be an example of this. You see how the soil is being pushed outward because of all the frost in the soil. The ice crystals are showing you how the water cracks get in there, it freezes, and it pushes out. I'm sure you've seen this in your yard in the winter after a melting snow or things like that. Thermal expansion. So actually, it's much easier to see it in asphalt. If you actually go down into our parking lot here at the high school, you can see how thermal expansion has caused the parts of it to bubble up and then gradually break down as things go over it. So it'll take a rigid substance, crack it, and then separate it. So that you can actually go to mountainside and see how different parts of the mountain are cracking off, and you have loose gravel there because of this thermal expansion and contraction. Exfoliation. So, and as underlying rock layers are exposed, there is a pressure on them and they expand. This causes rigid layers to crack and sections to slide off, similarly to peeling off outer layers of a skin during a sunburn, so often exposing into a dome. So think of as the pressure increases underneath the ground can start to bubble up. So it almost looks as if a rock hill forms. So when you see this, it gradually comes off and breaks apart because the rock is coming under so much pressure. If it is a rigid substance like a rock, it can break and fall apart. So abrasion, have you ever heard of abrasion in your skin or some sort of imperfection? So abrasion is the moving sediments of rock sections that can break off into pieces from a rock surface when they strike. So sediments can be moved by rock when underwater. If you look at the Grand Canyon, this would be an example of water abrasion because you have all these cliffs because of how the Colorado River goes through this ravine. Now, wind abrasion can show you how there is some sort of wind beating down on the rock. So for instance, this rock is out in the middle of a valley and is not protected from the wind. So it will gradually break it down and smooth the surfaces. You can even see the layers of the rock as they're older and younger, depending on what they are. So the older is on the bottom, the younger is on the top, and they're still being broken down by the wind. Water abrasion, so go to the coastline, you'll see all these different little pieces of island that have broken off from the mainland. That would be your water abrasion. This is showing wind and water because the wind is still exposing the top because you're not getting all of the water to rush up against it. Now, if you have higher waves, higher tides, that's where you see more water abrasion on the surfaces. Plant growth. So just like ice wedging or frost wedging, we have plant growth, which creates a wedge between the surfaces where they are. So if they find a crack in a rock, it is possible for that rock to be hospitable enough for that plant to grow. But as that plant grows, have you ever seen a tree grow out of a fence post or grow around the barbed wire of a fence? Well, this is exactly the same thing. So you see it is growing outside of, like out of this rock and breaking the rock apart, which can cause some sort of weathering, like this rock right here. So chemical weathering is different. So we have the process of hydrosis, oxidation, and dissolving. Dissolution is what we call it. Dissolving is what you think of it. So dissolving is when you have an acid from carbon dioxide. So when we talk about acid rain, this would be a dissolution or dissolving process. So it will dissolve minerals from a rock body, leaving cavities in the rock. Or these cavities can leave a spot open for frost wedging or plant growth, or they can create sinkholes or cave-like features. So when we see stalactites, limestone caves can show our stalactites and stalagmites that form because of this dissolving. It'll dissolve the rock into some other form and creating these cool stalactites and stalagmites. Oxidation is when minerals combine with oxygen to form new materials. So they're gaining these oxygen atoms and creating new things. So for instance, when iron contains a oxygen, so iron containing mineral pyrite or pyrite forms a rusty colored mineral called limonite or limonite. So this means that gradually it turns into a new substance because of the addition of oxygen to it. So you see this nice, beautiful pyrite that turns into limonite because of how it interacts with the oxygen. Hydrosis. So when you think of the word hydro, think of water. So it combines with the water, so with the hydrogen or dihydrogen monoxide to create a new minerals. So this isn't just dissolving or things along those lines. This is something new. So for instance, feldspar, when you combine it with water, it turns into clay. So think about how clay is found inside the earth. So without that water, it is just feldspar. So chemical weathering deals with plants and animals' time. So the longer something is in contact with something, the more likely it is going to change. Plants and animals react and they secrete waste that can create this reaction with the rock. Climate, if it's wet and warm, it maximizes more chemical reactions because the warmer something it is, the more likely the particles are going to interact together. Mineral composition. So depending on which minerals are found where, you're going to have different kinds of chemical weather. So important things to remember. Regolith is a rock blanket which composes small rock, and when organic material is mixed with that regolith, it is now soil. So regolith is no biological organic matter. Organic matter in it means it is soil. That's why we call regolith moon dust. So erosion factors, you have water, whether that be rivers, rain, glaciers, ocean, or wind and gravity. So a stream follows whatever path the least of resistance. That means that it will take with it whatever silt and sand. That's why we see in history that a lot of settlements are around rivers because that's where the most fertile land is, because the streams create this nice silt level that travels as it goes along and creates this beautiful topsoil that's good for vegetation. That's why you see a lot of vegetation along streams and rivers. So as the stream and river erosion decomposition, you can see that there's erosion on the cut of the bank, and eventually, when it gets to a point, it will take off more and more of that and take off our bank as well, because it is reaching its maximum velocity at this area that is creating a good point to break down that rock. So where the water moves more swiftly, there will be more erosion. So the slower it's moving, you're going to have less erosion. It will gradually wide out to where you see it. That's why when we see the river, the Colorado River in the Grand Canyon, you see a lot more erosion there because it's a much faster moving river. So ocean dynamics, tidal action will create that breakdown. So you can see in this picture right here, as it is breaking down, and even though there's man-made objects to try to keep that form, it will still break it down because the ocean is much more powerful and will break down the rock as it moves along. So any kind of movement will create that motion and break down the rock. I would suggest to go to both of these. They're pretty cool videos that show your ocean dynamics and how it works. Glaciers. So glaciers are less of a factor now, but over the history of our Earth, we talked about it with Alfred Wegener, how glaciers are a big part of how he thought Pangea formed, and it makes sense because glaciers are large ice fields that slowly flow downhill over time. These glaciers, these glaciers are just large frozen blocks of ice that will gradually move and cause a scraping and breaking down of the rock around it. So as it drags the rocky material and scores the surface of that it flows over, and they will break down these deposits of debris, and you'll see it over long periods of time as it melts. Wind transport. So I've talked about this, or I will talk about this, or I have talked about this, or I've told all my students about this when I was a history teacher as well. So you learn about the Dust Bowl and think about how far the wind took this topsoil over thousands of miles across the country into the ocean. So it's taking all this sediment and it is breaking it down to where if you take inches off the surface, now you're getting to different areas of sediment that you wouldn't be used to. So actually right now you can see it was worse during the summer or during the first part of fall. You can see how the photo shows the Sahara Desert being transported across the Atlantic Ocean. We actually had it make landfall with the United States, which means that the wind is transporting it very high in the atmosphere. It's pretty crazy that it's possible to do that. And gravity. So we talked about earlier in this how we had rock slides that can take it. So mass wasting. So that means weathered sediment transported down by gravity. So if it weathers down through water and it erodes the water underneath it, you can see how gravity can take apart what it once was, because it is taking something that is way unstable and just dropping. Because the more weight you have, the easier it is for it to fall with less of a support. So when sediments are weathered, they may come down as a slump. So you can see how all this was there and now it is slumped down to a new position. And so this is called scree. So there is actually a scree field or a scree hill over, if you go down Seckman, down Lyons Den into Old 22, that will show you your scree field. Okay, so deposition. So this means that we're taking it and moving it into something else or adding it to a new landform or mass. So it creates something new. So deposition formation is a transported sediment from one spot and deposit it in the layers and somewhere else. So you can even see how and we use it in time-wise, the older a rock is, the further it is down, or the older fossils are, the further down they will be. So that shows us time. So strata of the soil shows us how old objects are. And the deposition formation is what we call the strata. Don't, if you want to, you can do this. You do not have to feel obligated to do so, but it is an optional tutorial if you would like to do that. That is all for today. Sorry this ran a little long, but I figured we could get it all done in one video.